Hi everyone. So in the last lecture we were discussing this third normal form. 3NF we have already seen. Now let's see some questions. This is the first question. In 3NF, can we have transitive dependency? In 3NF, can we have transitive dependency? Tell me. Can we have transitive dependency? Tell me. Can we have transitive dependency in 3NF? In 3NF, third normal form, can we have transitive dependency? Yes, we can have, right? Okay. So yes, possible. So we can have, for example, you can have transitive dependency. There is no problem with transitive dependency. For example, if you have like R, A, B, C, D. So consider this one. A, B, let's assume they determine each other and A determines C. So this is in 3NF, right? Yes or no? This relation is in 3NF. Why? Because there is no non-prime attribute. In this, there is no non-prime attribute. We do not have any non-prime attribute. So in this relation, there is no non-prime attribute. Okay. So this relation is in 3NF because we do not have any non-prime attribute. So there is no problem. There is no violation of 3NF. But can you notice there is a transitive dependency here? Can you notice there is a transitive dependency? This, look at this. This is a transitive dependency. This, not this. AB goes to C. Can you notice AB goes to C? This is a transitive dependency. AB goes to C. This is a transitive functional dependency. AB goes to C. Okay. Because if you notice AB goes to C, AB goes to C, AB determines C. This is a transitive dependency because AB can determine A and A can determine C. And you can notice A cannot determine B. Okay. So this, you can clearly see that this is a transitive dependency. But remember, so you can notice AB determining C. This is transitive. But this is not a problem for 3NF. This is not a problem, right? For 3NF, this is not a problem. This is your candidate key. This is your prime attribute. This is your prime attribute and transitive. So this is not a problem. Prime attribute can be transitively determined. Yes or no? Prime attribute can be transitively determined by candidate key. That is fine. Yes or no? So like, okay, let me ask you some true false question. Some true false question. Let me ask you. So the first question, in 3NF, a non-prime attribute can be transitively determined by, okay, can be transitively determined by a candidate key. By a candidate key. Tell me, what about this statement? Is this statement true or false? This is your first statement. Is this statement true or false? So this statement is basically false, right? Because this cannot happen. A non-prime attribute transitively determined by a candidate key. This cannot happen. This can never happen. Okay, in 3NF, this is the problem with 3NF. What about this one? A prime attribute transitively determined by candidate key. A prime attribute transitively determined by candidate key. This is fine. Okay, can be. So this is fine. There is no problem here. Here we don't have any problem. We don't have any problem with the prime attribute is transitively determined or not. Is this clear? Prime attribute is a non-prime attribute. So this means attribute. Okay, here this means attribute. A prime attribute can be transitively dependent. There is no problem. Okay, let's see the third statement. In 3NF, a non-prime attribute can be determined by another non-prime attribute. So this statement is false. This statement is false. This is the problem. Okay, so a non-prime attribute is determined by another non-prime attribute. This is a false. So this cannot happen. Okay, so like this. Anyway, what is the definition, final definition of 3NF? What is the final definition? What is the final definition of 3NF? In 3NF, okay, I can say no non-prime attribute can be transitively determined by any candidate key. Yes or no? By any candidate key. This is the 3NF definition. Okay, so very simple idea. Now Let me ask you one more thing. This is my question. See, candidate key partially determines non-prime attribute. Candidate key partially determines non-prime attribute. Okay. So this is a problem for 2NF, right? If this happens, then this is a problem for 2NF. You know this. If this happens, this is a problem for 2NF. So I can say this is a 2NF violation. You can say this is a 2NF violation. Okay, this is your 2NF violation that we already know. Some candidate key partially determining non-prime attribute. This is a 2NF violation we already know. Now what happens because of this? Because of this, what happens? So you know that because of this happens. Because of this happens. That proper subset of candidate key determining non-prime attribute, this happens, correct? Okay, so because of this happens. They are equivalent to each other. Okay, now again, now you tell me, what about this one? Just look at this proper subset of candidate key. Is it a super key? This is not a super key. This is not a super key. Correct? Not a super key is determining non-prime attribute. So this is a problem for what? So you can notice this is a 2NF violation. So this is a problem for 2NF. I can say this is a problem for 2NF. This is equivalent to this. So this is also 2NF violation. Okay, this is equivalent to this. This is also 2NF violation. And you can notice that this is 2NF violation. This is 3NF violation also. Can you notice this is 3NF violation also? Yes or no? Now this is 3NF violation also. So can I say that 2NF violation implies 3NF violation? If you have 2NF violation, then automatically you have 3NF violation, right? Yes or no? If you have 2NF violation, then automatically you have 3NF violation. So I can say that. So if no, okay, and what is the, tell me. So this is the idea, very simple. What is the contrapositive? What is the contrapositive? The contrapositive. What is the contrapositive? The contrapositive, if you are in 3NF, there is no 3NF violation, then there is no 2NF violation. So I can say that if a relation is in 3NF, so if a relation is in 3NF, then it is in 2NF also. Is this clear? Then it is in 2NF also. Okay. So this is the idea. Now let's check it out. Let's take your copy pen. So let's do some practice. So tell me what will be the answer for the first one. B determines C. So first of all, what are the candidate keys? You find what are the candidate keys. So B determines C. C, D, C, A. So B. Okay, just check what is B plus. Check what is B plus. Let's do some practice. Check what is B plus. B plus is BC. That's it. Okay, B plus is BC. So what is the candidate key? So candidate key can be, for example, what about BD? So BD, if you notice BD plus will be BDCA. Okay, so this will be the BDCA. Next, so this is definitely a candidate key. So if you see the candidate key, then BD is a candidate key. What else? What about CD? What about CD? Sorry, CB. CB is not a candidate key. CB is not a candidate key. Okay, what else? CA. Sorry, BA. What about BA? What about BA? So BA will be BCA. BCA. Okay, and that can return. Okay, so this is also. So you can notice AB. This is also candidate key. These are the candidate keys. So anyway, what is the non-prime attribute? Tell me what is the non-prime attribute? B, okay, so non-prime attribute is C. C is the non-prime attribute. Now you tell me, what is the method 1? Is this in 3NF? What is the method 1? Just check. Okay, just check. Is this in 3NF? So you can notice this is C. This is the non-prime attribute. This is the non-prime attribute. This C. This is the only non-prime attribute. So which type of violation you will look for? Tell me which type of violation you are looking for. You are looking for not a super key implies C. Not a super key implies C. This is not a super key. Not a super key. This is not a super key. Not a super key implies non-prime attribute. Yes or no? Is this clear? Very simple. Not a super key implies non-prime attribute. So this is the violation. So I can say, so not on 2NF. Sorry, not in 3NF. So it is not in 3NF. Is this clear? Let me know. So this is not in 3NF. This relation. What about 2NF? What about 2NF? This relation R. What about 2NF? Do we have proper subset? Yes, you can notice this B goes to C. You can notice, so not 2NF. So not 2NF also. This is the violation. Yes or no? This is the violation. Proper subset of candidate key. Proper subset of candidate key determining non-prime attribute. So this is not 2NF also. So this is not 3NF, not 2NF. What about 1NF? What about 1NF? So this is in one normal form. That will always happen. That will always happen. Okay, what about, so this is the idea. Now, actually you can notice there is a transitive dependency. So you can notice there is a transitive dependency because you can, I can say that this BD determining C, this is a transitive dependency. Yes or no? BD determining C, this is a transitive dependency. You can clearly see this is a transitive dependency. Yes or no? This is a transitive dependency where this is a candidate key, where this is a non-prime attribute. So this is the problem. So this is the problem. This is a transitive dependency. Why this is a transitive dependency? Tell me why this is a transitive dependency. Because BD can determine B, that can determine C, and B cannot determine BD, and B cannot determine BD. Yes or no? So picture perfect. You can notice. Okay. So this is your perfect photo you got. So this is your transitive dependency. So candidate key transitively determining non-prime attribute. Candidate key transitively determining non-prime attribute. So this is a, I can say, so definitely this is not 3NF. Okay, so what is happening here? You can clearly see what is happening here. So I can say that here what is happening. So candidate key is transitively determined non-prime attribute. Okay, transitively determining non-prime attribute, and hence this is a problem. So not 3NF. Okay, so this is quite easy. Now let's see the option number B. What about option number B? Tell me, what about option number B? What is the candidate key? C, C, D, D. So AB, just check it out. The candidate key will be, I think, AB. It will be AB. AB can determine AB. AB can determine C. Okay, AB can determine C. ABC can determine D. ABC can determine D. So this is your candidate key. So your candidate key is this. Check for 2NF. Is this relation in 2NF? Just check for 2NF. This relation. This relation, is it in 2NF? What is A plus? A plus is A. What is B plus? B plus is B. So this is in 2NF. You can notice in 2NF. This relation is definitely in 2NF. Yes or no? Because the subset of candidate key, you can notice the subset of candidate key is A plus is A and B plus is B. So this is in 2NF. Agree? Okay, so this is very simple. Now, why this is into enough? Is this clear to everyone? Please tell me. Please tell me why this is into enough. Is this clear to everyone? This is into enough because this can never happen. This can never happen. Subset of candidate key determining non-prime attribute. This can never happen. This can never happen. Subset of candidate key determining non-prime attribute. This cannot happen. Not possible. So this relation is not into enough. Sorry, this relation is into enough because this is not possible. So 2 enough. What about 3 enough? What about 3 enough? So this is into enough. Now what about 3 enough? So here again you can notice that non-prime attribute. Can you determine non-prime attribute from a non-super key? From not a super key. From not a super key. Is this a super key? AC. Tell me, is this a super key? AC. AC. Is this a super key? Is this a super key? This is not a super key, right? This is not a super key. So not a super key determining non-prime attribute. Not a super key determining non-prime attribute. Is this clear? Not a super key determining non-prime attribute. So not 3 enough. Is this clear? Not a super key determining non-prime attribute. This is not a super key and this is determining non-prime attribute. So this is the problem with 3 enough. What is the method 2? Method 2 is transitive dependency. Okay, can you create this type of transitive dependency? Can you create this type of transitive dependency? This type of transitive dependency? Yes, we can create. I can say that AB determining AC determining D. Can you notice? This does not determine this. So this is your perfect photo. So I can say that AB determining D is a transitive. This is a transitive. AB determining D, this is transitive, where this is candidate key and where this is a non-prime. Where this is candidate key and this is non-prime. Tell me, is this clear? Okay. So this is another method. Another method. So you have this type of transitive dependency. Yes, correct. So this type of transitive dependency you have. Yes. So not 3 enough. What about the third one? What about the third one? What about the third one? So what about this one? What is the candidate key? Tell me what is the candidate key? A, B. So basically D must be there. D must be there. So, but D alone is not enough. What about AD? AD can, A can bring B, ABD. Okay, so AD. Yeah, that is fine. AD is there. What else? What about BD? BD is also there. BD also will be there. Okay. What about CD? What about CD? CD. CD is not a candidate key. CD is not a candidate key. Okay, so these are the candidate keys. So tell me, what is the non-prime attribute? What is the non-prime attribute? AD, BD. So C is the non-prime attribute. Okay. Now you tell me, is this into enough? Is this relation into enough? This relation, is it into enough? Can a proper subset, can a proper subset determine C? Can a proper subset of candidate key determine C? How many proper subsets are there? Just check. How many proper subsets are there? Just check all of them. Just check all of them. What is A plus? A plus is ABC. So yes, A can determine C, right? A plus is ABC. A plus is ABC. So A can determine C. So A can determine C. Okay, this is violation of 2NF. This is violation of 2NF, right? This is violation of 2NF. Tell me why this is violation of 2NF. This is violation of 2NF. So no 2NF. So no to 2NF. What is the method number 2? What is the method number 2? Method number 2 is, this is a candidate key. Method number 2 is this. AD determines C. This is partial. Why this is partial? So this is candidate key. This is non-prime attribute. This is candidate key. This is non-prime attribute. And this is partial. And you can notice this is a partial because A can determine C. So you can notice that this is partial dependency. AD is determining C. This is partial dependency. So not 2NF. This is not into NF. If something is not into NF, if it is not into NF, then it is not in 3NF. So this is not into NF. If something is not into NF, then it implies not in 3NF. If something is not into NF, then it is not in 3NF. So this is not in 3NF. But what is method number 2 for checking what is the violation of 3NF? Where is the violation of 3NF? Tell me, where is the violation of 3NF? The same violation will work, or you can give some other violation. The non-prime attribute is C. So you cannot give non-prime to non-prime. Nikhil, you cannot give non-prime to non-prime because there is only one non-prime attribute. There is only one non-prime attribute. Are the same violation will work? The same violation will work or not? This is also violation. AB determining C. This is also violation. Can you notice this is violation? This is violation because this is not a super key. This is not a super key. Correct? This is not a super key. And this is non-prime. And this is non-prime. So this is a violation of 3NF. What is another violation of 3NF? What is another violation of 3NF? The same. The violation of 2NF is also violation of 3NF. The violation of 2NF is also violation of 3NF. This is also violation of 3NF because this is not super key. Because this is not super key and this is non-prime. So this is also violation of 3NF. The violation of 2NF is also violation of 3NF. Where is the transitive dependency? Where is the transitive dependency? Where is the transitive dependency? I can say that AD can determine A, it can determine C. So you can notice this is a transitive dependency. So there is a transitive dependency. You can notice that AD is transitively determining C. Is transitively determining C. Okay, so this is the transitive dependency. Now let's move on. Tell me about the so this third one. This is a violation of 3NF. What about the last one? What about option D? Tell me, what about option D? What is the candidate key for option D? A, check A because A is not on right side. So check A plus. A plus is only A. Okay, so let's check AC. Let me check AC. So what is AC plus? That will be ACD, and AC can determine B. So AC is there. A must be there. C, and you can notice AD is also there. What about AB? What about AB? AB is not a candidate key. AB is not a candidate key. So what is non-prime attribute? So what is non-prime attribute? Non-prime attribute is C. Sorry, B. Non-prime attribute is B. Is there any problem here? What about 2NF? What about 2NF? So let's check 2NF. Let's check for 2NF. So this is your non-prime attribute. Can a proper subset of candidate key determine this B? Can proper subset of candidate key, can proper subset of some candidate key determine B? What are the proper subsets of candidate key are there? Tell me. How many proper subsets of candidate key are there? How many proper subsets of candidate key are there? There are three. Okay, tell me, can A determine B? Can C determine B? Can D determine B? Just tell me this point. Can A determine B? Can A determine B? No. Can C determine B? Can A determine B? No. Can C determine B? No. Can D determine B? So no. So what it means? So it means there is no violation. So into enough. So the relation is into enough. 2NF is quite easy actually. Just check all the proper subsets. Yes or no? Is this clear? Array, just check all the proper subsets. Just check all the proper subsets. Just check all the proper subsets, nothing else. And this is the non-prime attribute. What about 3NF? So this is in 2NF. What about 3NF? It's just all about understanding. Once you understand, you will never forget all these things. Just work it out. Okay, take copy pen and just work it out. Yes, proper subset can contain multiple attributes. Mavit, yes, proper subset can contain multiple attributes. Okay, now tell me about 3NF. So this is in 2NF, 3NF. Tell me. So can you create? Okay, can a non-super key? Can a non-super key? Can it determine B? Can a non-super key determine B? Can a non-super key determine B? This is your. So can a non-super key determine B? This is what we are checking. Can a non-super key determine B? So single attribute cannot determine B. In the double attribute, what are the non-super key? Not containing B, because don't worry about trivial dependency. Don't worry about trivial dependency. What about CD? Can CD determine B? No. CD also cannot determine B. CD also cannot determine B. Okay. So what about three attributes? So yes, this is not 3NF. This is not possible. Non-super key determining B. This is not possible. This is not possible. So 3NF. Is this clear? Why this is not possible? Tell me. Tell me why this is not possible. Just check. Just check what are the non-super key. Just check what are the non-super key. You can notice that. And remember, not containing B, because if it contains B, then what will happen? Tell me. If it contains B, then what will happen? If it contains B, then what will happen? It will become trivial dependency. It will become trivial dependency. So how many non-super key you have to check? Basically containing only A, B, C. So single attribute you can check. Single attribute is not determining B. And double attribute, this CD is also not determining B. So there is no problem. Okay. So you don't have any such a problem. Not possible. So this relation is in 3NF. Okay. So this is what we have done. What about this one? Is this in 3NF? Is this relation is in 3NF? So can I give this as a homework? Okay. So take this as a homework. Let's take this also as a homework. Okay. Take some questions as a homework.